Thank you all for being here today. Building net new applications or modernizing legacy applications using event-based architecture is an effective way to modernize your applications using events and asynchronous behavior to achieve scalability. What happens though when the business events and characteristics dictate that that's not enough? That's Maren and I'm Jeff, and over the next hour we're going to introduce where and how to include AI and agents into your event-based architecture to meet those needs of your business. First, we're going to set up the scenario that we have here at our company, the Unicorn Gaming Shop. And we're going to play a couple roles here. Apologize that the cartoons don't look exactly like us, but this is what licensing provided us.
Thank you, Jeff. So my name is Maren. Welcome in my name also. So I am an application product owner. I'm new to this company. I have 20 plus years of experience in doing these things. Basically, this company, I am tasked to define new features to drive the greater customer satisfaction. The main thing is we want to expand, and we want to try to automate as much as possible our customer interaction on one side, but we also want to help our engineers in the backend when we have an issue with the application, any type of issue, to help them out and to speed up the process when they need to resolve some issues. Also, we want to automate part of the resolution process. So the only most important and most hard things come to our backend engineers, which will then step in and resolve the issue. We want to lower that response time for our troubleshooting process.
And I'm Jeff. I'm an experienced software developer, and I've been working at Unicorn Game Shop for quite some time. I've been modernizing that application over the years using event-driven architecture and EventBridge. And I'm tasked with maintaining and building the new features that Maren's coming up with for the Game Shop application that we have.
And of course, I do have lots of new features. I am new here, I need to prove myself, and I definitely have some big ideas for this company. We need to expand. We need to expand to increase our customer base.
Really? Great ideas, Maren? I'd like to hear some of these things.
You may not like some of them because they're really big ideas. So basically, I signed 10 new deals for our company, and that will drive actually 50 times user growth what we have now. So I think you have your plate full for this one, Jeff.
Did you say 10 and 50 times more growth?
Exactly.
Thank you.
Please.
That's quite a task that he set me up for. Some of the things that I'm immediately thinking about when I have to deal with that is the scale that that's going to cause in terms of the overload to the team that I have. How about having the operational visibility about everything that's happening across this dynamically scaling and growing system? I'd like to use AI, but I got limited experience with that, both myself and my team, and I got limited team, limited time, limited budget. Now, I mentioned before that I've been modernizing this application that we have here using event-driven architecture and EventBridge. And EventBridge is the core of what our architecture is right now that I have in the system. And EventBridge really is providing me three things. One, it takes in the events that are coming from any one of the producers that we have here. In this case, it's my application. And then I have a bus, and I can have three different kinds of buses. I can have the default bus, which integrates with the APIs of AWS services, the custom event bus, which I'm using to handle the particular events that we have in our system, or the SaaS event bus. And then the rules is the third part of this. And the rules dictate what happens with the event that comes in and where does it go to. Now, I've been coupling that with using the leave-in layer architecture pattern. The leave-in layer architecture pattern is where I have a legacy system up here, and I'm building net new capability in that system off to the side of it. I'm building that using EventBridge here to handle particular transactions that I have here that were business features that Maren came up with before, which is introducing an event-based chat capability to our customer assistants who could answer questions asynchronously with customers that we have who are purchasers of games through our Unicorn Game Shop. And it works well, but I'm concerned about how that's going to scale with the amount of growth that we're going to be having here. Based upon what Martin's telling me, with 50 times more users, that's going to be overwhelming to our customer service assistant. And how am I going to maintain the operational observability and everything that's going on with all those logs are getting produced by all these new things that are happening? I could use my system as it is right now. Technically, it'll work. It's serverless, it's event-based, all the messages flowing through there are asynchronous. However, it only scales to the customer assistant. The customer assistant has to do the research to answer the questions that come in from the customer, and it's slow. It's slow because the customer assistant's doing a lot of work here, and they're gonna get overwhelmed. I've been doing a lot of research, and I've learned that I can introduce AI to help me out here. And in the AWS world, AI really comes in what we call Amazon Bedrock. And Bedrock is our service that provides API access to both AWS first-party models as well as third-party models from the leading providers. What I like about this is with this API layer is I can integrate that into my system without binding myself to any particular model, and then I can learn how my system is providing the answers that I want to my customer on the far end, and I can change the models as I want over time. I can also fine-tune my models to even get better quality in terms of the results that I'm getting out there. So I'm really interested in how I'm going to put this into my system to really start to drive the results that I want with the customer that I have. So I built a little chat that I can use, a research assistant chat from my customer assistants. My architecture is still serverless, it's still event-based, it's still asynchronous. Now I have research augmentation here through the integration of Bedrock in there for that customer service, the customer assistance person, and it is faster than it was before. However, it's still not fast, and it still only scales to the customer assistant. In doing more research, I got even more information about this idea of agents. And what really intrigues me about the agents is they are autonomous systems that can understand requests, make decisions, and act autonomously to do tasks. This sounds like a great way to augment that customer assistant and scale to the business that I have. And when I think about the agents, they come in a couple different styles. First, I can be thinking about agents that do department level tasks, which are things that are going to require data that's very near, typically things that aren't going to be terribly complicated, and maybe the security is not that strong in that area. Organization agents will work across the boundaries of my systems, maybe across the boundaries of my lines of business inside my company, usually greater access to data. Security is going to start to become a little bit more important here in terms of who can access what. And then external agents, which are going to be working outside the boundaries of my application, outside the boundaries of my company, interacting with third-party APIs and third-party data. I absolutely need a lot of control in what's happening in there. And as I think about this, I think about how am I going to manage all of this in this world, and how am I going to run it? And that's where Amazon Bedrock Agent Core comes in. And it provides three things for me. First, it provides the tools and the memory that my agent needs. And the memory is really important because a lot of times when you're doing prototyping with agents, they're very short-term memory, meaning you give them a task, they do it, they forget about it when they're done. You ask them a subsequent question and they got to go redo everything they did the first time. With this, there's memory built into this through Agent Core to that agent. So when you ask subsequent questions, they remember what is theirs before and you can chain everything together. Second, it provides the runtime environment and the identity management of the agent so that I can then control who can access that agent and what that agent is allowed to do. This is important to me because that agent that I have is going to be producing recommendations, is going to be interacting with a large set of data, and is going to be responding back externally. And third, the observability. There's going to be a lot going on in this system as it scales, and it's going to be producing a lot of decisions. I need to have the observability not only into the logs that are getting produced from the transactions that are happening here, but I need to also be able to kind of audit and observe how that agent made the decisions that it did so that I can train the model even further to make the decisions even more in line with what I want going forward. Now, as I think about bringing this all together in my application, there's two real patterns that I'm focusing on here with my existing application and how I would be integrating and incorporating agents for the decision making that I want to have in here. And this is where everything kind of comes together with Event Bridge and the agent. So first, the first pattern, Event Bridge triggering agents. In this case, events are coming in from any number of sources. It could be S3, it could be a schedule, it could be Lambda. In my case, it's going to be this web application that I have that has a chat built into it. The messages come through as into Event Bridge, and Event Bridge is going to invoke Bedrock to go do something. In the case that I have here, it's going to be go do some research based upon what the customer is asking for and provide back a recommendation on what could serve the need of that particular customer. The second one is agent-triggered event-based, agent-triggered Event Bridge events. This is kind of the opposite of it. This starts by the agent doing something, doing some research, making a decision, looking at something, and then it producing an event that gets put out onto Event Bridge that can then work in a fan-out kind of pattern to say, anyone who wants to do something based upon this event can now go do something based upon this event. Together, these two patterns are going to help me greatly in how I need to both handle the concerns that I have around producing this game recommendation feature that I want to have for my customer assistant, which is really going to be the first pattern. And then how am I going to handle all this operational observability that I have and maintaining kind of the site reliability with everything that's going to be going on in my system. So first, agent-powered game recommendation. I have my system as it was before, and what I'm doing here is I'm introducing the agent that I built, which is going to act on the information that it receives from the event, which is the chat that the customer is having to say, I'm interested in new types of games, I like these kinds of things, what would you recommend for me? The agent is going to get that, and the agent can do a couple things. First, before it even does the research, you can ask the agent, you can have the agent work to say, determine the sentiment of this person. If they're positive or maybe they're neutral, you probably don't need to have a lot of touch with them. You can have the agent kind of offline handle that themselves. But maybe the person's calling to say, your games stink, I want my money back, I don't like what's going on here. Here you can have the agent make a decision and say, I understand the sentiment, this person probably needs to go talk to another person, I'm going to route that to my customer service agent. However, we build good games, and we think that's going to be a small amount of the transactions. So when the event comes in, the agent can first determine what's the sentiment, who should I be routing this to? When it decides that it should be handling it, it can go do that research, gather the information, provide the recommendations back out to my customer. Now, remember, because this is also built using Agent Core, which has the first thing, which I said was the memory, there can be a chain set of conversation going back and forth here, and the agent's going to be consistently remembering what is before and building all the responses based upon what it knows and not having to redo all that work that it did the first time. One, that saves time. Two, it saves money because the agent's not incurring more cycles to go reproduce stuff that it already did analysis on. So this becomes the way that I can introduce that first pattern, that event bridge triggering agents pattern, to solve for this problem that I have about building and scaling game recommendations for my customer. That solves one of my problems. My second problem is site reliable engineering. So I have my system, and it's all instrumented with CloudWatch. And now that my scale's growing 50 times, I'm producing a lot of logs. And my engineer that I have, remember, I got a limited team, limited budget, he's going to become overwhelmed with having to understand what's happening in there and look for things that need to be dug into and where maybe something is trending bad, something needs to be fixed, something needs to be done. So the CloudWatch logs are growing exponentially. As good as I build this system, guess what? Errors occur. And sometimes they're minor and sometimes they're major. Either way, they need to be looked at. Here, using CloudWatch, I can set up CloudWatch alarms based upon particular things that could be happening erroneously in my system. Based upon those CloudWatch alarms, when something goes into an alarm, I can invoke my agent. I can invoke my SRE agent. That agent can do a couple things. First, it's going to be able to understand what's happening with that particular alarm, and it also understands the architecture of my system and the implementation of that system to say, what could that possibly be the root cause of? It can then determine the severity of that. Hopefully most of my issues are low severity type of things, and it can be a quick fix kind of thing, but some might be high severity. And similar to what we had in the first pattern, it can make the decision that I want high severity ones to get dropped as an SNS message that my engineer is going to pick up, and hopefully these should be a small amount of those things. But for the ones that are low severity or medium severity, I want the agent to go fix it themselves. And maybe I can build a little something there that when I have that, the agent can go, maybe redeploy some code for me somewhere else, maybe shut down a failing server. It can do the things in my system that my engineer used to have to do, but now they can do it fully autonomously. Now this thing can scale out very large to that 50-time volume I want without overwhelming that engineer, and it'll do it tirelessly and it'll do it repetitively. So here's how I can introduce that agent-triggered event bridge pattern to solve for that problem. Now, that combination of the agents in the system running on agent core with that memory and the runtime have allowed me to both scale to meet the need of the business that I have, as well as scale to that operational support that I need to have. And it's providing wonderful results. Now, it's great to hear about all this stuff, but it's even better to see a demo on how this all gets built. And with that, I will hand it over to Maren for the demo.
Okay, I got it from the first time. So, as Jeff explained, and you can see this is a recording. There is a reason why this is a recording. We did not trust the demo gods that everything work on the stage. So just to make it safe and secure that it's actually going to run and show everything we want to show, we recorded the demo session. So I will go through it. It's about 22 minutes long. So please bear with me while we go through this. We will show two cases. So as Jeff explained, first case will be helping our customer agents to help our customers look for similar games that they want to play, to offer them some similar games that they already played, and to enable customers to interact with the agent, in this case AI agent, that will give them some proposals. But additional layer on top of that will be that they will be able to provide a sentiment or some kind of, let's say, feeling, do they like something or don't they like something, so the agent can then, based on that, rephrase the proposal and give maybe different list of games to play with. Second demo, which is a bit longer one because it has more components, will be the one including our engineer in the backend, where we will see mostly stuff in the console and in the code that supports our engineer to resolve cases much more faster. So the logic is, again, as explained, that we will have an alert triggered by a quote-unquote fake Lambda trigger, which will go then to event bridge, and then that alert will follow through agent core, which will then go through LLM, seek additional information about the problem, and then decide is that problem low, medium, or high severity, and based again on the sentiment of the problem, we'll send it either to some auto remediation, which can be restart the service, start something, stop something, run a code or whatever, or if it decides it's a high level problem or issue, send an email to engineer to escalate further into the case. So we'll go through this together. Hopefully, let's see. Can I hide this? Yes. So this is our folder with the project, and you can see multiple different files that we will be using, like instructions and so on and so forth. We'll go through those files later on to show what they contain. Here we are activating Python environment because we are using Python to communicate back with an agent. And also here we need to install requirements. As you can see, most of these requirements are already satisfied because we ran this environment previously. Here I will run the application itself. I will stop briefly here. The application itself is basically running Amplify front end to be used as a UI for the customer to interact with. I forgot to mention that the agent core and Amplify is running locally. So it's running locally. It can run anywhere, of course, but in this case it is running local. And as you can see, basically it is loading the instructions file. The instruction file contains prompt engineering for the agent to understand how to behave. And also, interestingly enough, we'll see later on, it contains some additional data about the sentiment, basically how to determine what type of sentiment is customer producing to the system itself. I hate when it doesn't show everything. Okay. Let's deploy the front end. Amplify should jump into the front end itself. The front end itself is based on React, so that's how it's based. You can of course use whatever you want in this case. And this is our front end. Doesn't look super pretty. It's just for this purpose that we use it. Our assistant is called Gus. Of course, we can ask Gus, "Hi Gus, how are you?" He will respond with the information, what can he do for us. So this is me, again, as a customer interacting towards the agent. I'm now giving him information on what I like or what I used to play, what type of games I used to play. I'm typing slowly. There is also on-purpose mistake in spelling, so just looks natural. But Gus is very smart and he will very easily recognize what I actually need or what I'm actually asking. So this is going towards the database, of course, in the backend, which we will see different tools that have been used in the code to help Gus understand what I'm actually asking. Because we will see in the first run of this iteration, Gus didn't find anything. He didn't understand anything. But then he reiterated based on some keywords, based on the tables in the database, based on what I was saying in my question. And he went back, rerun the code, created the query needed to get that information from the database, and then gave me some information. As you can see, there are multiple different information that he gave me. What I don't like, I'll just give him now some sentiment that I don't like Resident Evil because I scare easily. So that's not something that I like. I want to tell him don't propose anything that is similar to Resident Evil. Of course, there is another spelling error. It's not event, it's Resident Evil. But again, Gus is very smart in this case and will very easily understand that error. So here, basically, we see what is happening, my interaction with the agent itself, what I'm asking. He's preparing the memory. You will see at the end, sentiment analysis enabled. Interesting thing, my first question doesn't have any sentiment. I'm just saying, what am I into? I'm in adventure games. I like to play this type of game, and that's it. So there is no sentiment related to it. Sentiment comes when I say I do not like games of type of evil one or ones which I'm scared easily. So you can see sentiment neutral, no sentiment here, because there is no, that's my first question. He will start to run it. Interestingly, again here, by using the tools, the agent is generating the query needed to ask the backend database what I want to show. You will not see SQL query in the code. There is no hard-coded SQL query that tells go do this. There are just instructions of what I want Gus to do. There is no embedded code into the query. Records found 0. So you can see, created a query, select console genre from the table, and so on. Records found, 0. Didn't find anything. Now, I'm just calling him he, I don't know why is it or he. So the agent will reiterate, rerun the code, add additional stuff like action or genre like adventure, and then we'll rerun it and we'll find 15 records this time. He will rerun it again, considering this is maybe not enough to show, and he will find some additional queries. Also at the end, not there, but the next one, so you see additional records returned 5 by not additional, but basically rerun again and shortening the list. Now we have sentiment, me saying I'm scared of Resident Evil games, which is basically now giving sentiment to the agent, telling him that this sentiment now is negative or not, or bad. I will put it that way. So he needs next time to avoid giving me any results containing similar games. If we go into the code itself, so you can see here those are instructions that I mentioned. Within those instructions are instructions on how agent needs to behave, what agent needs to do, how to communicate with me and give me back information that I need from the agent. On the bottom itself, you will see also sentiment when we come to it. So instructions, prompt engineering, classic, and on the bottom, sentiment monitoring. So as you can see, the agent continuously monitors conversations and then decides what type of sentiment is it. Is it a good sentiment? Is it a bad sentiment? So I could have said, no, this is, I like Resident Evil games, give me more of that, or I don't like, as I did, don't give me more of that. In the application file itself, which is a Python code, we have lots of tools defined. So we have tools like tools that will go to database and extract information, tools that help agent generate that SQL query that will then bring me back the results. Also, we have other tools that will help with the sentiment generation. So I cannot go through the whole code itself. Unfortunately, it's also very small here. We have different, again, instructions. We just saw that. Let's go to some definitions that basically define how the agent responds back to me. And again, in all of this code, you will not see any query. There is no SQL query saying what needs to be done, because then it wouldn't be agent-based. It would be just a SQL query based on some keywords which I provided in the tool. Entry point for the agent. So basically, it is based on invocation, totally asynchronous as mentioned, which is the idea. I don't need to be waiting for something to happen. I need to happen immediately back and forth. Okay. Session ID, user ID, and so on and so forth, everything. Of course, for this to work, LLM is running in AWS. So you cannot run your LLM locally as you are currently running this agent core and Amplify. So you need to have your credentials, you need to have access to your backend where your database will be and the agent logic or LLM that you're actually questioning. Sentiment, so you can see it can analyze sentiment. It always analyzes sentiment as you enter something and interact with the agent itself. We can go to definitions, how to analyze. So how to analyze sentiment and how to output back to event bridge. Once you have this in event bridge, you can then do whatever you want, basically. But in this case, we are just providing feedback back to the customer how to create it. I'm so sorry, this is like silent session, and this is my first time doing it. I used to have interaction, people asking questions, so it's weird having you like aliens with those red ones. Yeah, cool. So code, basically Python code that helps out in this interaction and defining how all this in the backend works. Again, the most important thing is to understand this is the event bridge part where we basically send all that information, sentiment, confidence, summary, back to the user to understand that part. Okay, so I will stop here for a second. The second part, basically, as explained, is, so this is the first part. What can you do with this? So there are so many agents that, of course, are already pre-built, or you can just reuse them and so on. This one is interesting because it's very easy to deploy. You can run it, test it locally, and then push it to AWS and run it in there if you wish. So this is just a concept that proves the concept of basically asynchronous communication between the customer and the agent in the backend, and reusing existing LLMs to provide additional data. This was like super easy code. It's super short. It's not long, and it can be very easily tested. And this is like with user interaction. When I'm prompting questions and asking, give me this, give me that, and so on and so forth. And this is all based, of course, on your existing knowledge that you possess in the backend of the database of all the games that you have. Second part includes a bit more components, and second part is, I would say, not as interactive, because the idea is that we have a permanent watcher or alert-based system. This time it is through CloudWatch, where we are basically generating an alert and then sending that alert through Event Bridge to Agent Core, which then decides the sentiment of that alert and then does some action. And this is something that is totally autonomous versus the first one where I need to input something, ask back and forth, and interact. Here we do have the alert itself. As you can see, the alert was set up, in this case, maybe not for production, but like every one event with one data point, then raise the alert. And then I have a rule in the event bridge, basically, that is watching for those alerts, any change of state, and it has a target of agent core to do something with that alert. So we will see later on what that agent core actually does. So the important thing is that I am not just sending him again, or it. I'm not just sending it, oh, there is an alert. I'm sending him, okay, there is an alert. You need to go back to the CloudWatch logs. You need to pick up some additional information about that alert. And you will see later in the code we have, again, additional tools that do that and then do something with the code. So this is Agent Bedrock. I will stop quickly just here because Jeff also mentioned some of these. We are using Agent Runtime in this case, but there are additional options that you do, like built-in tools, gateways. We even did some upgrades recently on API gateways in this tool. Memory also mentioned, identity is super important, and we will see later on observability also super important for this, because you don't want this running wild, not knowing what is actually happening, how many invocations do you have, how many times your Lambda fired because something happened. You want to fine-tune it either because of the resource usage, cost usage, or just optimization of the code. So we are currently using here Agent Runtime for this particular agent core. So again, alert, I have a fake Lambda, you will see later, that will trigger a couple of alerts. Again, nothing to use in production, just for demo purposes. That will go to Event Bridge. Event Bridge will send that to Agent Core. Agent Core has instructions. You will see again instructions file is a bit different one, and this one is not called Gus, it has much more ominous name. But it will then look, oh, there is an alert, let me go back to CloudWatch, let me collect some additional information, let me determine the sentiment, and let me then decide what to do with that information. So what this is doing is actually relieving our engineers that they don't have to be there for each and every event, but they can basically just get the top level, highest priority events and then act on them. Okay, so this is the agent. Maybe one thing to notice here is just it's a version 7. I have run this multiple times, so once we come to the end and run it again, so when we go through all the files, it will be agent version 9, I think, because we have run it multiple times. So there is versioning, of course, within the agent. We can see the invocation code itself. In this case, Python. Blur some things which contain sensitive information. So it's very simple code. Multiple versions, currently 7. Once we run it actually again, it will be 9. additional information about endpoint itself. You can add tags if you want, of course, when it was created, status ready, and so on and so forth. Okay, this part, super important, observability. This is the thing that you definitely want to have. You want to be able to have insights into the processes, what is actually happening inside. You can, of course, change the range when something is happening. Here, I'm changing it for, I think, 4 weeks, because I ran it 4 weeks before. You see how many endpoints, how many sessions, traces, error rates, and so on. So to see this information, session invocations, and so on, so you need to enable this in Bedrock. So there is a checkbox, basically, or switch that you turn on that then enables invocations, and then inside we'll just go now into that part, into Bedrock, where you can see basically what types of invocations you want to log and where do you want to store that information. So going to Amazon Bedrock. In my case, it will be turned on because I already turned it on. So settings, and then here, let me stop quickly. Did I stop? No, I did not. Here, stopped. So this needs to be turned on, model invocation logging. If you don't have that turned on, you will not see that data over there, which is not good. You want to have that data. What type do you want to include into log? I included all text, image, embedded video. Where do you want to store that? S3, CloudWatch logs only. I will just store it in a CloudWatch log in this iteration. Okay, let's go to CloudWatch, to CloudFront, to see what was deployed. So to see what was deployed, there were multiple resources deployed through CloudFront for this. I will stop quickly when it loads. Okay, so let me hide this. I hate how it doesn't hide. Come on. Okay, forget it. So we have Lambda Event Bridge Agent Core. So that's when it comes to Event Bridge invokes Lambda that then talks to Agent Core, talks and tells him, okay, there is an event, investigate. Lambda Error Generator, that's the fake generator for errors, where I will click several times just to generate some errors. Error alarm itself, Agent Core SNS topic, which will be used to send an email to engineer in case the severity or sentiment of the error is high. And then we have the role SRE itself and some metadata on the bottom. So and all of these have adequate permissions to access all these services. So you can really scope the permissions for each of these to have access only to what it needs to have access. Now let's go to the project file. It is similar to the one that we already saw. So it's similar to the projects that we already saw. You see requirements, you see instructions. The instructions are, of course, different. It's not the same thing. I'm instructing, in this case, I'm instructing the agent to, when it receives an alert, and when it sees the alert, to go back to CloudWatch to collect additional data about that alert, and then based on that to decide what level sentiment it is. Also, I am using several different tools to get additional information about the tool and about the alert, and those tools are defined in the code itself. So I want to get log group name, query. I want to create CloudWatch log insights query, when it started, when it ended, and so on and so forth. So, and then on the end, I also you will see, I also instruct the agent to retry at least 2 times, if it can, to do it. So get more information tool, notify high severity problem tool. So those are all the tools that the agent use once it gets more information and determines the sentiment of the problem itself. Everything in the instructions file. So better you do this better results you will have. Again, some error handling, you should always have some error handling. It's not the best or smartest one, but at least it's there for the tool to know, to agent to know what needs to be done. Again, application, Python application. This application defines basically once the agent starts, how it starts, what tools are available, and what instructions are there, and so on and so forth. So preloads everything into the service. I have been using for this CLI, which basically in the backend builds container. It deploys Docker container to ECR, then deploys agent in it, and runs it through that. And the tools itself, they are not invoked immediately. Of course, when the tool is deployed or agent is deployed, they are invoked after something happens. So there are two parts of this, you may say. The first part is how to start the agent, what are the instructions, and what tools are available. And then second part, when something happens, event-driven, right, as we are talking all day, then what to do with it, what tools to use to construct proper query, so to collect data from the logs, and then to basically decide what level of severity the issue actually is. So all of this, we haven't even seen our engineer yet. This is standing in the background of the service, listening for those alerts, and then triggering when needed. So these are the tools that I have mentioned, either tool for sentiment, tool for generating query, tool for getting additional data on the log file. Because I cannot decide sentiment, or the agent cannot decide the sentiment based just on there is an alert. It needs to go back, collect the alert, and then basically decide the sentiment and what will happen next. So those four, as you can see, arguments: log group name, query start time, and end time. Of course, when that happens, it triggers Lambda, which will then go to agent and determine next possible steps. Query, ECS service, Lambda, RDS, and so on and so forth. So again, it can be send a message, it can be restart service, it can be run code, it can be whatever is needed. Now the question, of course, here is how much automation do you want to give it? Do you need to have somebody in the middle, like a person that will go through this and validate if something is wrong? How much power you want to give to these kind of services while restarting, rebooting, changing, modifying, or sending some commands to something to be something done. So okay, here we are deploying the basically agent core from the terminal. It will generate the Docker container and run it. Use all the instructions in the application Python code and collect all the tools that it needs to basically run the agent. Two lambdas, as I said. We have one lambda that is like dummy lambda for generating code. That's the one on the top, lambda arrow generator. And then the second lambda is basically to be as a middleman between the event bridge and the agent core itself, which then defines, again, all those tools and how to access that information. This is just a simple code generator, which just trigger a couple of codes once we go back into the console to see how that gets triggered. And the result, which I'm sorry to say is not super spectacular, but it will show you what actually happens. So let's go back, agent runtime. Let's see what happened. As you can see, version 9. So there was one version in between which we didn't see. I ran it for test purposes. So this is now version 9. If we go to Lambda functions, you will see those two Lambda functions that we are basically talking about. This one is to communicate with the agent core. No, this one is to generate event, right? Yes, test. So this one will, I will click it multiple times. It will just send some few fake events. Expected errors, again, demo gods, so even recorded one. But it sends, so it sends to CloudWatch, and you will see a couple of events in the CloudWatch. Let's see that part. Okay, so as you can see, several events generated from Lambda. In real life, of course, this would be something that happened actually in the production. Again, alarm that is triggered, change state. It says when state is changed, go run, go into create event bridge event. And then now from there, when you are here, we are choosing to send this to agent core. So that's one of the options, where the agent core, with all those instructions, everything will decide the severity and everything else. But once in here, you basically can do anything. So this is the beauty of event bridge from previous options that you had. But here, again, I see two events happening. Again, back to Lambda. For the other one, the Lambda that will actually talk to agent core. And that has instructions to do what? To go back to CloudWatch and look for more information on the problem. So again, you will see here that it has been triggered. It's a small trigger, but it's there, so you see that it has been triggered. Let's see the logs itself. So this is what's happening. And here, let me stop quickly here. So here you can see the full log of what's actually happening. Lambda errors, and inside here you can even see that it's going back, instructing that it's going back to the CloudWatch and basically saying, okay, I need to collect additional information on this error, and I need to define the sentiment of this error. Again, there is no query anywhere. There is no SQL query. The queries and all the queries are generated on the fly based on the information provided from the log. It is at the end a JSON payload. As you can see, severity high. So severity was determined to be high in this case. So it could be low, medium, high. Again, we decide what is low, medium, high. I mean, we decide what action happens if low, medium, or high. In this case, it's high. So high severity notification sent. Let me stop here. So as I said, not very spectacular result, but this is what went to our service reliability engineer. This is the email he got. You can make it more prettier. It doesn't have to go to email. It can go to a ticketing system with a high priority assigned to somebody and so on and so forth. But this is basically the idea. The general idea, as Jeff explained, is to actually automate part of this on a super easy way with the technologies that basically were already there for most applications in event-driven architecture. We are just adding on top of it some smarts in a way that let me reuse existing LLMs, but give them on top some of my own quote-unquote knowledge from the logs that I'm collecting, and then utilize that to offload work from our people, from engineers that need to resolve those issues. Of course, at the end of the benefit of the customer for the application. So I hope I managed to put it a bit closer for all of you to understand what is the possibility and how to enhance your existing service application that you don't need to build up everything from ground up. So yes, Jeff, and I will close up now. Thank you.
So
that's good. Yeah.
hopefully that demonstrated how by starting with building your architecture in an event-based manner using EventBridge and then incorporating agentic agents into that process can help you scale to deal with characteristics that you might have previously thought from your business. And with that, we got Maren, myself, we're happy in what we built, our customers are happy, our engineers happy, and our and our customer assistance happen. With that, we thank you very much for your time today. We thank you for coming to reInvent, and we're going to be hanging around a little bit longer if you have any questions for us. Thank you very much.